Hello, I'm Mudit Bansal. Today I'm going to show you how to predict the price of house in Boston. We are using the Boston House dataset containing 13 attributes and 506 rows. We are also using various libraries such as Pandas, NumPy, sklearn. First of all, we load the Boston dataset using load.boston. As you can see, these are the attributes. Then we copy the values of these attributes on the variable features. We can access the attributes in this format. From the Boston dataset, we can set the value of the variable target to the target row. We can perform various functions such as max and min function. We can concatenate the target dataset with the Boston dataset. Now the table has 14 attributes. Then I have rounded off the last two decimal places. Then we correlate the attributes with the target. We use the Pearson correlation for this. We found out that LSTAT was highly correlated with dataset. LSTAT corresponds to lower class families and hence it influences the price of house by reducing it. I stored LSTAT in X and target in Y for ease of access. Then I printed first 5 values of the target dataset. Then I normalized them to the scale of 0 to 1. I pass these values to the train test split function. Then I define the gradient descent function for performing the linear regression. Then I pass the values to the gradient descent function. Feel free to pause the video at any time to have a look on the code. Here is the model. This is the curve of the graph. Then I made an animation of this graph and a video too. Based on the actual value and calculated value, I calculated the mean squared error. Then I created a table which shows the value of x, the target value, and the one which is predicted here. I then plotted a graph of this. All these values are in a normalized range. We need to convert them back into the real scale. So I converted them and these are the actual values. Till now we used LSTAT which was the highest value. Now we are going to change it to next highest value which is RM. As you can see, the mean squared error is higher than the previous one. So it means that it is not as accurate as LSTAT. Then we use the attribute which is least correlated with the target which is TAS. You can see here that the mean squared error is even more than what we wanted. Thanks for watching.